Welcome to This Explainer. Okay, so have you ever had that incredibly spooky, almost universal experience where you're just going about your day, maybe, I don't know, thinking about a hyper-specific niche hobby like underwater basket weaving, or dreaming about a random vacation spot in Croatia, and suddenly you open your phone and the very next video on your TikTok or Instagram feed is exactly about that? Seriously, maybe it's 2 a.m. and you find yourself trapped in this bizarrely specific rabbit hole that perfectly aligns with your weirdest unstated interests. It leaves us all wondering the exact same thing. Is my phone actually listening to me? Well, today, we're going to unpack exactly how these systems operate.
Our core mission in this explainer is to really pull back the curtain on this exact question. Because the truth is, this eerie, mind-reading feeling, it isn't magic. And spoiler alert, your phone isn't eavesdropping on your conversations. It's simply massive-scale math. It is literally all math. Over the next few minutes, we're going to trace the journey of a single scroll to see exactly how artificial intelligence figures you out.
Section 1. The Mind-Reading Illusion. Finding patterns in the noise. To really understand this, we have to grasp how modern machine learning completely breaks away from the past. You see, traditional software is incredibly rigid. Think about the apps you used maybe 10 years ago. A programmer had to sit down and write explicit manual rules for every single thing the software did. You know, if A happens, then do B. But artificial intelligence operates entirely differently. It learns the rules on its own by analyzing vast oceans of data and identifying patterns within that noise. The algorithm doesn't read your thoughts, and a human engineer didn't write a rule specifically for you. Instead, the system is highly engineered to analyze millions of examples of human behavior to identify hidden patterns that you might not even realize you have. And because it learns from these dynamic examples, the algorithm seamlessly adapts to you even as your tastes and interests change over time. Which naturally begs the question, where exactly is it getting all of these examples about you?
Section 2. Tracking your micro-interactions. The data collection phase. Notice the fascinating contrast here between explicit and implicit actions. On the explicit side, well, we have the obvious data points you knowingly give the app. That's when you physically tap the like button, leave a comment, or hit share to send a video to a friend. But the real secret sauce, the reason the algorithm feels so unnervingly accurate, lies in the implicit actions. The algorithm is gathering data from absolutely everything you do, down to the literal millisecond. Imagine you're scrolling and you see a looping video. Maybe the text flashed by just a bit too quickly, or you missed a tiny detail in the background, so you let the video loop and rewatch it 3 times. You didn't double tap to like it? You didn't comment? You might not even care about the creator, but by letting a 5-second video play for 15 seconds, your micro-interaction just fed the neural network a very clear, powerful signal about your attention. The app captures every hesitation, every screen pause, and every fast swipe. So once the app collects these thousands of micro-interactions from your daily scrolling, what does it actually do with them? Let's look at how it translates that very human behavior into cold, hard data.
Section 3. Mapping you with vectors. Translating behavior to math.
To understand your complex human preferences, the AI needs a language it can actually process. And here's the big aha moment. Computers process numbers, not concepts. They don't know what a funny cat is or what Croatia is. So the system uses something called a vector embedding. In plain English, a vector embedding is a brilliant way of translating your scrolling habits and the videos themselves into long arrays of real numbers. It represents your interests as physical points in an imaginary mathematical space. By turning abstract concepts into concrete numbers, the system gains the ability to mathematically measure exactly how similar 2 pieces of content are, or how closely your interests align with a highly specific niche.
Think of this vector space like a massive geographic map. In a large language model, the word Paris maps mathematically very close to the word London because they share similar context, right? They're both major European capitals. The word cat will be clustered right next to dog, kitten, and pet. Now pivot this exact same logic to your social media feed. The AI analyzes the features of millions of videos. It mathematically determines that a video about skateboarding belongs in the exact same neighborhood as a video about sneakerhead culture. If your micro-interactions show you pausing for an extra half second on a skateboard trick, the math automatically knows you're sitting right next door to sneakerhead content in that vector space.
But notice how AI models don't just use a flat 2D map like the ones we look at for navigation. No way. They use vector spaces with hundreds or even thousands of dimensions. While our human brains physically cannot envision a space with 1,000 dimensions, computers are perfectly capable of effortlessly navigating this complex geometry. In a fraction of a second,
The algorithm calculates the exact distances between thousands of invisible variables. I mean, it maps the 120 beats per minute audio track, the neon color palette on the screen, the pacing of the cuts, and the specific text overlay. It pinpoints exactly where your highly unique, multidimensional interests overlap with the content. But mapping your interest isn't just a one-time static event. You change, your moods shift, and the algorithm constantly adapts to keep up.
Section 4. The AI feedback loop. Learning by trial and error.
The crucial point for how it adapts relies on a concept called reinforcement learning. Think of this exactly like teaching a dog to sit. When you give the command and the dog obeys, you give it a treat, a positive reward. When it disobeys, it doesn't get a treat, a penalty. Over time, the dog naturally learns to repeat the actions that earn those rewards. AI agents learn in the exact same fundamental way. The algorithm is constantly testing your preferences in real time, receiving positive mathematical rewards when you watch a video all the way through, and negative penalties when you aggressively scroll past a video in milliseconds.
Let's walk through the exact three-step loop the algorithm uses every single time you touch your screen. Step 1 is exploration. The agent tries a random move. It might show you a video slightly outside your usual vector cluster just to see what happens. Step 2 is feedback. You either watch the video or you immediately skip it. This is where the treat or the penalty is delivered. And step 3 is adjustment. The agent updates your mathematical profile based on that split-second decision. And what is truly mind-blowing here is the scale and speed of this process. This entire three-step loop executes in the literal milliseconds it takes for your thumb to swipe up to the next video, continuously and endlessly refining your feed.
In this system, the agent continuously updates its policy to prefer moves that lead to wins or higher scores. What does that mean for you as the user? Well, in the mathematical game happening behind the glass of your phone screen, a win for the algorithm is successfully holding your attention. Every second you stay on the app, the algorithm's internal score goes up. It's relentlessly recalibrating its internal weights, adjusting thousands of mathematical dials, and acting with the sole, programmed purpose to maximize that attention reward. So we've seen the data collection, the vector math, and the trial and error learning. Let's look at how all of this generates the final output you actually experience.
Section 5. Predicting your next scroll, the final output.
How does the system actually choose what piece of content to show you next out of billions of options? There's a major difference between a system predicting a simple outcome, like say asking a spam filter a binary yes or no question, and a system ranking options. Your social media feed uses ranking options. Think of it as a fierce, invisible competition happening in the background. The AI takes all your vector data, plus your entire reinforcement history, and it forces millions of possible videos to fight for the #1 spot on the podium. It scores them and sorts them from best to worst, mathematically tailoring a lineup designed to hold your attention right at this very second, literally before the pixels even load on your screen.
The overarching takeaway of this explainer is that the process underlying these personalized outputs is simply statistical pattern matching at a massive scale. It truly does feel like magic. It feels like the app is reading your deepest thoughts. But really, it's just millions of artificial neurons processing the exact amount of time you lingered on a video about a highly specific topic, comparing your behavior to millions of other users who behave similarly, and predicting the most mathematically probable piece of content to keep your eyes glued to the screen.
So I want to leave you with this final, provocative thought to reconsider your daily relationship with your feed. Every single time you pause, every time you let a video loop, every time you scroll, you are feeding the machine. But as it learns to perfectly serve your desires, shaping exactly what you see, what you think about, and how you spend your free time, are you training the algorithm, or is the algorithm training you? Thanks for joining me for this explainer, and hey, next time you scroll, pay close attention to those micro interactions.